Yeah, all good. Great. Okay. I just wanted to invite welcome you all to the first Agile Roundabout. My name is Robbie Dawson. I'm one of the organisers, and I'd just like to, I suppose, just say a few quick things about the group, tell you about what you can expect from us moving forward, and then obviously we'll introduce Zeeshan and get cracking. So I guess just to give you a bit of background on why we set up the group in the first place. I work for a software development recruitment company called TRG. We moved into Shoreditch about sort of 6 months or so ago, and I guess since then I've been hugely impressed with the software development community and the kind of sort of noticeable around here, the collaboration, the continuous improvement that people seem to adhere to, and these are kind of core Agile principles, and they're evident in the fact that you guys are all here today. Zeeshan's given up his free time to share some of his knowledge, and it's kind of these sort of principles that I think are relevant to all of us, not just within software development. And I really want to, I guess, help contribute to that, bang the drum, if you like, about Agile principles, which is why we wanted to do our bit and make our contribution towards making things easier, I suppose, for these principles to continue. So we'll be holding an event like this at least once every month, and I'll tell you a bit more about what we've got lined up in the next coming months. But before I introduce Zeeshan, I just want to go through a quick couple of things. You might notice we are recording the event this evening, so if you want to watch it over again, or if you've got friends who weren't able to make it tonight, it will be posted. Links will be posted online on LinkedIn and on the meetup group as well. We'll get that up and running as soon as we can. If not tomorrow, then certainly next week. Also, you can tweet about the event throughout the evening. You'll be able to see your tweets up on this screen here. And of course, I guess the obvious one is if you can just make sure your phones are on silent, just so that. And then I guess finally, obviously want to tell you a little bit about Zeeshan. I've worked with him for a number of years now. I'd say he's genuinely one of the nicest people I've met in software. He's got just so much time for anyone who asks for help. He's taught me far more about software than anyone else, and put up with so many annoying questions. So, and he's never ever turned down an invite to lunch. So I guess he was always my first choice for this first talk. He's a brilliant developer. He sets up a great team at his previous companies now. Just moved over to Aviva as their lead developer, technical team lead. Same thing. So yeah. I'd like to welcome Zeeshan to the stage, and hopefully it's a good talk. Hope you all enjoy it.
Sorry, my mic was, I think I haven't tested it properly. Can everybody hear me?
Yep.
Yeah? Okay. Thank you very much, everybody, for coming and listening to me probably for an hour. I hope I won't bore you all. So to start with, what we are doing here, first of all, we will talk about TDD. There are lots of different approaches people use, but one of the two most famous ones are London style, Chicago style, and what we will do is we will discuss a little bit, but most of the evening will be how we'll do actual coding and show you how we can implement them. And each individual approach, I will try using very basic example, but try giving you examples of the real life scenarios that how we can use them in real life. Is that okay?
Yes.
Yeah. I don't know if there was something wrong with it. Okay. First of all, learn and style. Does everybody knows about TDD? Anybody who doesn't know? Okay. So there's one person who doesn't know. Okay, there are more people. I hope. Anybody else? Okay. So, very quick.
I'll look online.
I'll take 30 seconds and very quickly. Most of you should know about unit testing. TDD is a little bit different approach to unit testing. What we do, whatever we want to test, we write our test first to find out that what we are actually trying to implement. And on basis of those tests, we try to implement what actually we want to implement. And once we have implemented, then we go back and refactor the code. In software development terms, some people call it red-green refactor. So make it fail first and then pass it and then go back and refactor your code. So that's the very basic view of it. So what is Chicago style of testing? Some people call it inside-out approach, and some people call it state verification. Why people think it's inside-out approach? It's inside-out because, in very simple words, when we are trying to do unit testing, we take very small bit. For example, we are trying to test a calculator. We will take a very small approach, very simple approach, 2 + 2 = 4, and we will implement that as a test, and then we will build up. So that will make it like inside-out approach, and we will build up. We'll try making it our calculator very maybe scientific calculator in future, and build up from small little tests. Why state verification? There are many ways of doing things in software development or in real life. For example, we are implementing a small method where sometimes method returns something, or method has internal calls which is calling external API, or it's calling different objects. With state verification, we want to see that what our method is doing or what our object is doing. So some of the methods they return a value, and that's where we see that, okay, if we are getting a value what we are expecting, that's our state of the object, and that's correct. That's state verification. And before I go into outside in and behavior verification, what I would like to do is open Visual Studio, and I already have very empty solution set up, and show you how we do it, and then we come back and talk about London style, and then implement that. What I have here is empty solution, no classes, nothing. I've just added a project with test project. I'm going to use NUnit for now, and I will do a bit of mocking, but not at this point. But for mocking, I will use MOQ. Does everybody knows about NUnit? No? Yes?
That's a lie.
Okay. So let's start. You might have seen, you have already probably seen that. So we are going to write this bus very simple example. But why I chose FizzBuzz? Because nearly everybody knows about it. Anybody who doesn't know FizzBuzz? Okay, there are a few people. I'm not going to go into very much detail, but simply you have numbers 1 to whatever, let's say 1 to 10, and if the number is 3, then it should print fizz, and if the number is 5, it should print buzz, and if the number is divisible by 3 and 5 both, then it's FizzBuzz. So it should print these two values. Okay. I didn't realize that I will have to look like this, not I won't be able to see this. Okay, so in TDD or wherever you're writing unit test or writing a method, you should give a reasonable name. So I will try giving a reasonable name. Okay. To start with, this is test fixture. Most of you probably know about this. So first thing I want to do is write a test where I want to write a test about that. The simplest test is the print fizz. There are different values we can pass and it should print fizz. And to start with a very simple example, I'm just going to take a variable with the value, or I would call it input to 1. So now there are different approaches people use, but one of the most famous is Aaa Principle. What it is you arrange your variables, you initialize your objects, and then you act upon them, and then you want to see that your assertions are correct. So in this, like I said earlier, TDD, you write your test first. You're writing your test first without writing any code or doing anything else. So what I'm trying to achieve here is that I have a service which, when I will call the services calculate method, it will do whatever it wants to do and return what I'm expecting. And in this scenario, when I'm passing 1 as an input, it should just return 1. And we will go on and build up on this, and I will try doing things quickly and not just do simpler things. So I will call my service, and I will say new FizzBuzz service. And then I will say service dot calculate, and here I will pass my input. At the same time, I'm expecting some result. And then here I'm saying that my result should be equal to I'm expecting a string as 1 in return. And so this is the very simple method nothing exists at the moment. We don't have the service, we don't have calculate method. To make things a little bit interesting, I would say that I have a calculator which actually does the job for me. And I don't know about the calculator at the moment. That gets injected to my service, and then service does whatever it needs to do. It might just calculate, it might perform some other operations. We will find out later. So here I'm saying that I have a calculator which I'm passing. Oh, I don't want this one. I want my calculator. And just give it a nicer name. Okay. Quickly initialize my calculator. Initialize my service. I'm going to leave the things as they are. And now I need my calculate method, which is in return I'm expecting a string from calculate. So what we have done here, that we started our test, we didn't have any code, start writing the code. So that's how we say that start your test first, write your code, and then hopefully it will fail. Then so coming back to again a couple of things. Sorry, I was using ReSharper, so I was trying to do things quickly. I don't want to stand here just writing code. So this is what we have seen is it's failing, but is it failing for the right reason? So it says method or operation is not implemented, which is basically we haven't implemented this. That's the wrong reason of test failing basically. This is not, if it is failing, that's not just as failing, it's failing for the wrong reason. We have to make it fail for the right reason. So in this case, I'm just saying return null. And I run my test again. What am I doing? Oh yeah, sorry. Yeah, so yeah, so we are expecting 1, but we have returned null, and so now it's failing for the right reason. Now we can go back and say that okay, our just in a very simpler way, we return 1, and it's passed. But that's very basic scenario. To make it a little bit more interesting, very quickly I will say that I have different test cases. It can be 1. For now, just 1, 2, and I will take here. So they both are passing now. But so now this is failing for the reason we wanted it to fail. And again, to make it quickly pause, we'll say that but that's what we don't want. We want more than that. So we add another test case. And it's 3, and we are expecting as a result. Yes. We'll have to change our test very quickly. Assertion, you can say and we were expecting that it should fail. And to quickly make it pass, we will just say that if it is divisible by 3, then return this as input or constraint. So the idea here is that we were expecting something from our calculate method. I know we haven't used calculator class yet. We will use a little bit later. And so this is very simple way of testing, which we call it Chicago style. If there were, for example, more dependencies, in Chicago style, you try to either initialize those dependencies there and then, or you can use doubles, or some people, they try using object mothers. Object mothers, in very basic scenario, object mothers are basically type of classes which can create objects for you. And whenever you need the type of object, they will do it for you, and they will send it back. So this is, in simple ways, Chicago style testing. We did not use any mocks or any stubs. Before I go about mocks and stubs, how many people know about mocks and stub? Okay, nearly everybody knows. I think it's a few.
Question or
Yeah.
I was just a bit confused when you were talking about failing for the wrong reason versus failing for the right reason. The code that you initially put up with the not implemented exception, for me, failed in a perfectly acceptable way, which I haven't implemented the code. That's an acceptable failure.
Yeah.
I'm now going to have my first attempt at.
But then, if you're calling that method for anything, passing any type of parameter, that method was going to fail.
Mm-hmm.
And you don't know, you know that that method doesn't have anything, but that method should be returning wrong value to make it fail. Or because you're expecting.
I felt that was an unnecessary step because it was failing. I wrote the first test.
But because you want method, you're expecting something from method, and if method is not returning that, then it should fail, not just an exception. Does that make sense? Yes and no. Okay. Some people will agree, some people will not. That's how software development is basically. It is true. It's real life scenario. Like you work with different type of different developers. Not everybody is wrong. Not everybody is right. You sit down with one person doing pair programming, you debate about something else, and the second person you sit down, that person will be perfectly fine with it. It's just
Software is not a democracy.
it's not.
You're right.
Okay, I'm wrong. So yeah, going back to London style. London style is outside in. Why do we call it outside in approach? It's so now I'm going to start using the term mocks. Sometimes we don't live in an ideal world. Sometimes we have scenarios where code is already there, but we want to do TDD once from now. And code was written like 2 years ago, but people didn't do TDD. But now company is saying that we should do TDD. So we want to start writing code, and we don't have test returns for everything. And we are, like we did before, that we are injecting some dependencies, and those dependencies are quite big. And to initialize those dependencies, you need to require more objects, and then more objects, and then more dependencies. So instead of doing all that, you can mock your dependencies, the ones you don't need. So in that case, again, why is outside in? Your object graph is already there. You want to start writing tests, and you can start writing tests from any point in time, and that's why you don't have to build the picture from the start. Why behavior verification? Sometimes not every method returns a value. Sometimes we call a method, and that method we expect it to call something else and do something for us, and that's where we say that it's behavior verification, and we need mocks for that. We can check that, we can verify that what kind of method was called. Sometimes we call a method and we expect it to call different methods and do different steps for us, but it doesn't return a value, or returns a value, but still we want to see that, okay, this method called 4 other web services, for example. So that's where we say that the behavior, that's what behavior verification is. Why do mockists use mocks? Because they like to. It makes their life easier. And that's how it is. Yeah.
So you said, right, as per the TDD principle, you first write the test, then only you do the code, right?
Yeah.
But you are saying London outside in,
Yeah.
code is there, you
Yeah.
write a test.
Yeah.
In that case, it's not comes under TDD as per principle, right?
Yeah. Yeah.
So,
But
yeah.
what my point is here, that you're doing TDD for a new requirement, but there are already objects there, there are already classes there. You're not writing tests for those classes. You're doing TDD for your new class, but still you need some of the objects from external classes. You cannot go and start writing tests for them as well. And you need to inject that in maybe your current classes, depending on the external classes. So you need to inject them. Either you need to mock them, or you want to call an API, and that's where things become a little bit complicated. So let's go back to our example and maybe try doing a little bit different way.
One last thing, if you don't mind.
Yeah.
So why this is called as a London style? London means you have the old code and the writing test. Chicago means you have new code.
There was a group, I can't remember the name of the group, and in that group they were using mocks a lot, and it became very popular as part of that group. I really can't remember. I think some people know. And since then it's called London style or mockist style, and yeah.
But even you can use mock in the Chicago style as well, right?
Yeah, you can use mocks as well. We will come back to that point later. Okay, so we're back to our simple test. what I am going to try doing is here, I might just copy it instead of. So here, before I change the name of the test, or I can change the name now, I'm saying that this was service calls calculators calculate method. It's not an ideal name, but for now it seems fine. And so what I'm expecting here, instead of using calculator, I'm going to mock the calculator. And I am in the assert, I will say that I am expecting that calculators calculate method is called with the input we have here. And that's my expectation here. I can still have my this case. We don't have our calculate method at the moment. Forget that. We'll leave it like that again. So what we are doing here? We had a dependency calculator, and we don't care about the return value at the moment. What we want to check is that calculators calculate method gets called with the parameters we have passed, and that's what we want to test here. Like I said earlier, that this is learning style where we don't care about return value. We can see. Let's try running the test.
You need to change the return value.
Sorry.
Can you keep it virtual?
Sorry.
Do you need to make it virtual?
Yeah.
You calculate.
Sorry. I'm looking there and then here. And then yeah. So here we are expecting that it should call our calculate method, but it's not calling. So to make it pass, go to our service and do like it. And here we will say that cause or calculate methods with our input values. Because here we are expecting string. So our expectation is passing. So the point here is that even though we haven't implemented the method, but we are expecting here that is still calling the calculate method with our expectation. Like your question earlier, that we can still use mocks in our Chicago style test. So those type of tests are valid, and those type of tests can be done, and in some ways we should do in some scenarios to verify that what we are actually doing is valid, the behavior of a method is valid. And now if I run my earlier test, now they are failing. They are failing for wrong reason, but they are failing for right reason. Now they are passing as well. So it turns out that in some scenarios we are happy with just Chicago style of testing, and in some scenarios we need both London and Chicago style of testing. Now again, these two examples are very, very simple. To make things a little more complicated or more interesting, I would say that I have a dependency of a validator. Yeah, sorry.
Why did you put the property get set if you are injecting the dependency? Shouldn't it just get?
Yeah, we can just use get. Yeah, I'm a bad developer. Sorry. And I should just change it now. Some developers, they don't like. Do I even need a property?
There's no
No.
private set.
Read-only field.
There's
Yeah.
no private set.
Sorry?
A private set.
Private setter?
So you do it again and then private
Private
set.
set.
I will just have the normal properties. Normal. Should I change the name as well? Sorry. Make it private.
Yes.
you know.
We don't we?
Now everybody happy?
The test passing.
Sorry. Oh, no, I'm not running tests now. I know they're gonna fail. I'm scared. And okay. Them anyway. Oh, they're awesome. And, sorry. Now we can refactor. Let's refactor. Do you want to refactor? No, we should refactor it. So how we can refactor what we have done? Our tests are passing. I don't like this because I know this is a little bit last minute thing. We know that we will have to at some point print buzz as well, so we can't just like do if else. Sorry. Yeah. So I'll write my test first. To do it quickly, make our life. Why my shortcuts are not working? Okay. So the requirement is that it should print buzz when it's spoiled, and everything else should be normal. Then I go back and run my test again. Everything else passes, but this file it doesn't like file. Let's go back to that. Oh. And for everything else, it should just do the simple thing. So yeah, we have done a little bit refactoring and also passed our tests. So now coming back to the point where I wanted to make things a little more interesting. So I'm assuming we have another dependency, which is a validator, where when we input a value, that validator goes somewhere outside in space, and takes 10 minutes and validates our value that the value is right or wrong. And when we are doing unit testing, we don't want to do that all the time. Like every time we run a test, it takes 2 minutes or 5 minutes or 10 minutes or 10 seconds. We just want to test, because we are not actually testing validator, we are testing our service. We just want validator to validate whatever we want it to validate. So I'm going to introduce validator here. This is wrong way of doing it. Write another test for him. Bring it up so everybody can see. So we are saying service throws an exception. Don't know what that exception is. When paused. Negative value. It can be any value, but we are assuming it will be negative value. I can still say it's input, and here I can say my case is -1, then I can say -2, and here I can say it's expected exception. Yeah. Yeah. It looks like more suitable one. Does anybody else like any other exception? Sorry. I can't make everybody happy, but we try. So what we're expecting here is we're passing negative values and we're expecting exceptions from our test or from our service. Again, we have input there. I'm going to initialize my service again. And it's expecting calculator. Then I am saying that it's expecting a validator as well. Oh. So in this case, I created a validator, but we said that our validator, we don't know about validator. Data it's somewhere else. Let's assume it's somewhere else. It's not there, but for this case, we have to initialize it. But I don't, because it's somewhere else. I just want to mock it, and I don't really need that validator. But what I want to test here is that whenever we pass wrong value, it should just throw exception. So I am going to mock my validator. Here, I can add a parameter. So now it's very heritable. So we can see that our first test has started failing. Like our project is not going to comply. So what I want here is the same thing. So your question earlier that we can still use mocks based Chicago style testing, and some ways Chicago style of testing is that where you shouldn't. People try not to use mocks, but if they have to, they use mocks or they use test tables or object mothers. In our case, we can leave it. We don't really care for now, but we care about it. And this test is for people who like mocking. They like mocking everything. So at the moment, I'm one of those people, so I'll mock everything. Initializing things here. That should be fine. Now back to In this case, we have our service, we have our validator. We are saying service dot calculate, and we are passing our input like we have done before. And in that case, we are expecting it to throw exception. So it's expecting an exception from it, but obviously we are not throwing any exception. So it's failed, we need to go back and make it pass again. This is our service. Doesn't like it. Nobody likes it. And in our calculate method, we are saying that if validator dot validate date method is called with the input. And if it returns false, we want to throw exception. Which exception was it talking about? Range. And we go ahead and validate method. So our point here is that we are expecting something from our validator and we don't have direct access to it, we don't want to do much with it. We are trying to avoid saving time with all our unit tests. So quickly, we will say to our validator that whenever we call our it should be that's the problem when you're looking like this. Trying to do it. And in our setup, we are saying that whatever happens, it should return false. We can do many things with it, but just to make things simpler, we are saying whatever happens, it should return false. And what we want from our service, what we are expecting, that when it's false, it should throw that exception.
Your feasible service seems to be depending on concrete validator class.
Sorry.
Shouldn't that depend on that? Shouldn't your feasible service, shouldn't that depend on an abstraction of the validator class, like an interface or something?
Yeah, ideally yes. Yeah. Do you want me to convert it to interface?
No. Because,
Okay. So yeah, so basic idea, I didn't want to go into too much details. The basic idea is that we have an external service where we don't have access to it and it takes a lot of time, or even if we do have access to it, it takes a lot of time. But in this particular scenario, we don't care about that external validator, we care about that our service, whenever some validator says that, okay, it's a wrong value you're passing, service should throw an exception. And this particular exception we are expecting from it, and that's what the idea behind it. So coming back to the same point again, we have Chicago style of testing, we have London style of testing. Both type of testings are valid, and some people like using mocks, some people don't like using mocks. In some scenarios, you have to use mocks. You don't have any choice, and it's quite valid thing to do. I personally, I mix and match. If things are very simple, I try to not complicate them using mocks and stubs and doubles and object mirrors. But if things are, which in real world scenarios quite a lot of times things do become complicated, then I try mixing it. Finish a little bit 5 minutes earlier than I was expecting it to be. Any questions?
Can I start?
I think we had a mic somewhere, but I don't know if you want to use it. It's fine.
I'll
Yeah.
try to put my voice as much as possible. But coming back to Chicago style,
Yeah.
so if I understand correctly, if your class A depends on class B, you would just pass the class B on its own.
Yeah.
It does not violate the principle of unit testing, where you're only supposed to test a unit and not its dependency. Because there's something wrong with the dependency, then you need to test that in isolation.
Yeah.
So I know you said mix and match. I
Yeah.
just found that being slightly invalid. That principle where you are clubbing your dependencies and testing, in a sense, more than one unit.
Sorry, he distracted me. But I understand your question. It's supposed to work, I don't know how. Sorry? Okay. Understand your point. I think what you're trying to say is that when in Chicago style of testing, if we are injecting dependency, and if there's something wrong with that dependency, then we are injecting a wrong thing into our class or testing wrong thing. But sometimes the point here is that we are not testing that whether that dependency is doing the right thing or wrong thing. That dependency is outside of the scope of the unit test. You are testing a unit. And to test that unit, if you have required multiple things, you should use them. And a lot of time you don't require most of the things which we have seen in the third type of test where we had validator, but the calculator wasn't required. We didn't care about the calculator. And so in those scenarios, ideally you can mock them, or if you have to initialize them, you initialize them. That's your personal choice. But if, like I said earlier, if the dependency is very, very big, and dependency has dependencies, when you start initializing those things, it can become very complicated very quickly.
you don't have any cost to use any box, and you want to do Chicago style TDD, which is basically testing state, right? If you have to call out to some kind of service at that point in the class, so you inject a concrete class into another class, then it ceases to come for unit test at that point. It just then becomes an integration test.
Yeah, it becomes an integration test. And like we said, we saw in the third scenario that we are mocking our validator. Still, that's not integration test. And if we had a validator, but that validator wasn't an external class, that was an internal class, but still it takes 5 minutes. It's part of the solution, it's the internal thing, is still a unit test. And we don't want to take 5 minutes just for one unit to run. And that's where still mocks are better. They are not just like good for external classes or external objects, they are good for internal objects as well. Yeah. I'm supposed to throw this, and you're supposed to be able to speak on this. I don't know if I can do that part. I'm going to try it. Not sure if that's going to work. Okay. Huh?
Imagine that you are testing very complex scenarios where you need to read data to take whatever decisions from the, you need to read data from the database, several tables, whatever. You are using an entity framework. Do you mock entity framework, or you try to isolate those calls to the database within the repository and then mock the repository? What's the best approach?
I think one of the ways of doing it is that you mock the repository, because repository is your repository and you should write tests for your repository. That repository is doing the right thing and getting the right data from the database. Depending on how you have implemented your repository, you just mock the repository. And I think Entity Framework provides you out of the box that you can easily mock the repositories. You don't have to implement that. Yeah. Yeah.
Hi, cheers. Just want to know, if you are running test-driven development properly all the way, does that mean you kind of have 100% code coverage?
No.
Okay, good. How much, well, for you guys, do you have like a cut-off point with regards to how much code you cover in all the tests?
There, from code coverage point of view, what I have experienced, people say that they do 100% TDD, but that's not, I mean, even I've done, I would say that was 100% TDD from the TDD point of view, but there are a lot of things like configurations and many other things which you cannot test. They're still part of your solution. I worked on a project where we did not write any code without writing tests, but even on top of that, there were lots of code, which was configurations and many other files which we couldn't test, but they were fine. And we had like TrimCity running with test running on each individual commit. Some of the unit tests were taking like half an hour, some were taking 2 hours, so we had to divide, we had to categorize the unit tests. It's much different conversation, but yes, even if you say you have written every code as TDD, still it's not 100%.
And one last thing, when complaints come in with regards to bugs, does the test team normally end up writing a test to prove the bug? I mean, is that how you can ask the test team when they're finding out to write the test, and then you just have to make that pass to prove that the bug comes?
So with my experience, we have done 2 different things. The teams I've worked with, most of them, they had a tester in them. And so when the bug comes via most of the time support team. Somebody will call support team and they will come to you. Support team will already say that, okay, we have tried, that this is happening when you do this. And our tester can go and validate that, okay, this is the scenario, and we will implement that scenario in a test, saying that this is happening and this should fail. And that's where our fail point is. This should fail, then we'll make it pass, and that's our real life example, is that that's how we fix the code, fix the bug.
Via an actual unit test.
Yeah, yeah.
So test-driven development helps you force that methodology on the
Yeah.
team.
Yeah.
Great.
Yeah, nobody else? And I think Rob has something else to say for, I think, a few seconds. I hope he doesn't have this, he doesn't have to use this whole thing to...
So obviously, thanks very much to Zeeshan for that. I think he's proved himself with test-driven development, but he's also definitely ruled himself out of my cricket team. So yeah, thanks for bringing that too. Yeah, so I just wanted to obviously reiterate thanks to everyone for coming tonight, and just to mention a couple of the other talks we've got coming up over the next couple of months. So next month we are doing a talk at Lend Invest, which is one of the fastest growing fintech companies in the UK. That's on the 28th of July, and that's going to be led by a chap called Nigel Wilson, who works for a consultancy firm, an Agile consultancy firm called Scott Logic. Nigel's spent many years working primarily in finance, so he's going to do a talk for us on agile development in regulated environments. And then on the 18th of August, we're going to be at the Agile consultancy firm Equal Experts, and some of you may know a woman called Helen Leake, who does some talks for Agile Coaching Exchange. She's going to do one of her talks on Kanban. So all these talks will be going up on, the details will be going up on the Meetup group, obviously on LinkedIn as well. And we've also got another talk scheduled with Camelot, the guys who do the National Lottery for September. We'll sort out a speaker and what that topic's going to be. But just keep tabs on the Meetup group. Obviously, Zeeshan's talk today, that can obviously be expanded upon, and we'll be getting Zeeshan back to sort of go into further detail as well, to take test-driven development a little bit further. So yeah, just keep tabs, and we'll get some more talks lined up. Obviously there are beers, pizza, wine, drinks, soft drinks at the back, so please help yourself. We'll clear some room for you guys to have a chat and stuff. Thanks for coming.